Find the infiltration rate of the soil after 4 hours in centimeters per hour. In this problem, a sandy clay soil with an initial saturation of 27% undergoes continuous ponding with a negligible ponding depth. The green ant equation for infiltration rate is the infiltration rate at time t equals the hydraulic conductivity times the quantity, the soil section head, psi, times the change in moisture content when the wetting front passes the dry soil, delta theta, divided by the cumulative infiltration at time t, plus 1. Infiltration parameters for green ant equations can be looked up based on soil type. For a sandy clay, the hydraulic conductivity is 0.060 centimeters per hour. The suction head is 23.90 centimeters, and the effective porosity equals 0.321. The change in moisture content can be determined by multiplying 1 minus the initial saturation by the effective porosity. So 1 minus 0.27 times 0.321 equals a delta theta of 0.2343. So already we know the hydraulic conductivity, suction head, and change in moisture content. The last unknown variable is the cumulative infiltration, capital F sub t. The cumulative infiltration at a time t equals the hydraulic conductivity times the time plus the suction head times the change in moisture content times the natural logarithm of the quantity 1 plus the cumulative infiltration divided by the suction head times the change in moisture content. Plugging in the known variables, the equation reduces down to F sub t equals 0.24 centimeters plus 5.6 centimeters times the natural logarithm of 1 plus F sub t divided by 5.6 centimeters. We notice the cumulative infiltration occurs twice in the equation, once in linear and once in a log. Therefore, we'll have to solve the problem iteratively, unless we have access to a special calculator. If we had a graphing calculator, we could plot the left-hand side of the equation as a function of f sub t, and the right-hand side of the equation as a function of f sub t. And the intersection point would be the correct value for the cumulative infiltration. To solve the problem by hand, we'll begin by simply guessing the cumulative infiltration in the soil after 4 hours of continuous ponding. Since the soil is a sandy clay, we'll guess 3 centimeters of infiltration. Then we'll plug this value into our equation and solve the left-hand side of the equation, which is just the cumulative infiltration itself, 3. Then we'll solve the right-hand side of the equation, which equals 2.64 when we guess 3 centimeters for the cumulative infiltration. From this first iteration, we notice the left-hand side of the equation is greater than the right-hand side of the equation. Looking at the graph, this condition is true when the guess for the cumulative infiltration is too high. So our second guess will be less than 3 centimeters. Using a second guess of 1.5 centimeters, the left-hand side of the equation is 1.50 centimeters, and the right-hand side of the equation computes to 1.57 centimeters. Now we have a situation where the left-hand side of the equation is less than the right-hand side of the equation, as would occur when the guessed value for cumulative infiltration is too low and should be higher. 2 centimeters is tried on the third iteration. The right-hand side equals 1.95 centimeters. Therefore, 2 centimeters is too high. For the fourth iteration, we'll try 1.75 centimeters, which is slightly too low. In our fifth iteration, using 1.80 centimeters converges. So now we found our cumulative infiltration. Returning to our equation for the infiltration rate, we now know the cumulative infiltration after 4 hours is 1.80 centimeters. And from earlier, we've already determined the values for hydraulic conductivity, suction head, and change in moisture content. After making these substitutions, the infiltration rate equals 0.247 centimeters per hour. When reviewing the possible solutions, the answer is A.